thing. Like so, ISTQB examination will be having two different levels: one with the foundation level and the with the advanced level. So anyone who needs to start with this foundation level. So there is no prerequisite to take this foundation level examination. That means that actually any graduate who has the knowledge on the testing, they can easily take this foundation level certification. So if we want to take the advanced level certification, we must have the working experience, and on top of it, we must hold this foundation level examination. So those two are the prerequisites for advanced level. So for foundation level, not required of any kind of prerequisite. So this foundation level basically examination having 40 different questions. Out of 40, we need to get 28 marks. Like so, probably it's around 68%. So 26 and above is like pass mark. So if you get the below 26, that is a fail of the examination. There is no negative marking here in this foundation level. So all we need to know about this is so one thing, like actually this examination will be divided into different knowledge levels basically. So here K in the sense knowledge levels, they have divided into different knowledge levels here. But in a foundation level examination, there are 4 different knowledge levels. The first one is like knowledge 1. This is the basic one. We have to remember few definitions. Probably in the examination, we may expect the questions from like what is what. That is definition kind of. So once you read that statement, you need to remember what the definition it is, for what we are defining that. Then the second is understand. That means they may give some kind of scenario. We need to read that, understand, relatively we need to opt the answer. The third is apply. That means whatever the theoretical knowledge you may hold, so that theoretical knowledge needs to apply in order to solve the problem. So probably in real time while we are working, so based on some instance, so we have to correlate our theoretical knowledge to resolve some kind of problem or else issue. So that's where we usually apply. So that is apply. And then analyze. Probably few problems will be given. So we need to read that and understand. Then we have to analyze this. Analyze in the sense, unless we analyze this, we cannot we cannot actually say that we are very good at testing. So one way, if we are taking the ISTQB syllabus, that means that we are going to be having so much of good knowledge in the testing. So because this ISTQB is given by the United this UK board, so not India. And one more important point is ISTQB is recognized throughout 67 different countries. So why do we need to take this ISTQB certification? So generally, actually, we observe that there are so many trainings going on the testing. So why specially we need to take the certification? So here there are 2 perspectives. One perspective from the candidate, another perspective from the company. Because here one thing is, we know that anytime if you hold some kind of certification, that represents your knowledge. So if I say I am very good at ISTQB, but no one believes me because I am just rendering from my mouth. But the thing is, I need to showcase something on behalf of my knowledge. Probably that comes through this certification. So the second point is, if we go through this ISTQB syllabus, then definitely we'll understand the basic content to the advanced level of the contents, and at the same time how we can apply this theoretical knowledge on the software. So these 2 are the very important points from the candidate perspective. Then why companies are looking for the ISTQB certified professionals? Because if any business company, they want to sell their products, what they do, actually they'll showcase their quality marks, quality brand. So probably the company will showcase the test engineers by showcasing these certificates, ISTQB certificates. So this company will say to the client saying that, so I have these many certified testing people, so you can aramse give your projects to me, then I can best test your application.
Yeah.
So that's the way actually they may get the business. And the second point is, for the managers, it's very easy to find out the skilled employee and get appreciated, or else they give the performance things, or else they appraisal kind of. So that is the reason actually here. So two perspectives. One will be advantage for the candidate and as well for the company as well. So that is the reason actually these days this ISTQB is more popular. And one thing is we need to understand. So generally in the market there are so many technologies. For an example, if I say software, so software means that so in real time there you can have so many problems. In order to resolve the problems, or else in order to make simplifying of the problem, you need to go for the softwares. So at your desk you are minimizing the time cost and you are finishing the task within very less time. So that is the way, that is the reason actually nowadays we are using the software applications very aggressively. So if we want to resolve the problems, resolve the real-time problems, we must definitely have the software. So if we want to implement the software, we must have the proper technology. Probably the technologies are like Java, .NET, SQL, Oracle. These kind of technologies we are using to implement the software. For what we usually implementing the software? So there are so many business areas there in the market. So for an example, so you already told that you have worked on the healthcare. So that means healthcare is a separate market. Probably as part of the healthcare, pharmaceutical will come, hospitals will come, so diagnosis centers will come. These all centers are using softwares. So then I'll say banking sector. In that banking sector, so bank transactions will be going. Financial areas, insurance areas, defense, aeronautical. So retail in the sense whatever Amazon, Flipkart, Snapdeal, these kind of applications. So these all various domains, I'll say. Domain in the sense the expertise on where you can find out the particular business area. So we implement software for these kind of domains. So now actually we are trying to understand. So we are basically using the technology to implement the software for the domains. So nowhere we are not talking about the testing. So now the question is testing technology, or is testing a domain, or is testing a software? So probably testing is not software, testing is not any technology, testing is not domain. Then what is testing? So what we can say? So if you go and ask the Java developer, so what you basically deal with, they immediately say that we are dealing with the technology, because Java is a pure technical thing. So now we want to say what is testing. So we must have the answer for it. So probably testing is a process in the sense. So you do follow some steps which can give the better result in a quality manner. That is basically testing. So testing is a process. So by following this process, you get the better results in a quality manner. So in order to achieve the quality, we are testing the software. How you are testing? By following some process. So process in the sense, then everybody is having their own process. For an example that, so if I want to pass some examination, so I have my own plan, how to read, how to understand, or else how to prepare for that exam. At the same time, somebody else also be having the same kind of plan. So suppose if I say process, then everybody can define their own kind of process to implement something and get the better results. Now if I say testing is a process, that means that anybody who has very strong in this area, they can define their own process and they can follow their own kind of testing methodology. So if all the members will follow in different manners, then the new people will get confused. Which kind of testing I need to pick up and opt? Because actually there are n number of processes in the market for testing. So now I'm getting confused to elect which one is the better. So this is the problem basically. So in order to avoid this problem, few certification bodies actually they form, like ISTQB, CSTE. So these are like different certification bodies. Now these bodies are framing one set of syllabus. That syllabus will be best useful for the testing. So if at all, for an example, if I take the ISTQB certification is popular throughout 67 countries. That means that if you learn ISTQB syllabus, then we can roam around the 67 countries and we can follow the same way of testing. That the way actually we can perform the testing in the similar manner, whatever the way the other country is following, because we all following the same kind of syllabus. That is the reason actually these certification bodies are most useful, and that is the reason the companies also insisting people to take the ISTQB syllabus, because so all the companies majorly they deal with the on-site, like the overseas business. So overseas business in sense, so almost Indian market is dependent on the United States and European market. So only US and European market we are getting the projects and we are doing on those projects. So obviously we must have the syllabus what they are following. So probably so this is the reason we need to look at this ISTQB foundation level syllabus. So this foundation level syllabus is divided into 6 different chapters. So the first chapter they're talking about the fundamentals of testing. That means so very basics, how we can understand what is testing and why testing is necessary. So in which way we need to look at this testing process. These are very basics we usually discuss as part of the first chapter, fundamentals of testing. Then it comes to the second chapter where actually we are going deep inside, like how we can look at the testing in the software testing lifecycle. So in how many levels actually we can perform the testing. So based on the context or based on the instance, then how we need to apply the testing. So these are like different levels of testing and different types of testing. So that is basically the second chapter. Then, so anytime if you are working in the software, so you may know about the software development lifecycle. So there are many phases like requirements, design, code, testing, deployment, maintenance. These kind of phases are there. Then testing always be done once we receive application software. Unless we have the software, we cannot test the application. So probably before we receive the software, there are many other phases like requirement phase, design phase, and coding phase. So even we do not have the application, we can perform the testing on the documentation like requirement documents, design documents, then coding documents. So if at all we perform the testing on these documents, that will be called as static testing. So in order to perform the static testing, we do follow so many techniques, either it is in a manual way or else in an automated way. That is basically the static testing. So now the fourth chapter is like once we receive the software, that means physical view of an application, how we are performing the testing on the software. Probably, so then based on the nature of the software, behavior of the software, we have to apply the appropriate techniques not to write the proper test cases to test the application. That is basically the fourth chapter, test design techniques. Probably where we discuss about the white box test design technique, black box test design technique. So how we need to write the test cases by using these all things. So we discuss all these as part of this. So if we look at the first 4 chapters, this is whole talking about the testing and its related process. Now, if we combine all these activities together and try to manage the testing, that is basically test management. So this is the high-level activity which will be usually be done by the test leads or else test managers. So how they prepare the test plans and how they track the effort of the associates. These are all things we usually discuss as part of this test. So, and the last 6th chapter is talking about like tool support for testing. So here we are talking about, so what are different automated tools we usually use while we are implementing the software. So in the total software development life cycle, so what all tools we can use, or else in the testing phase, what all different tools we can use to automate our services. So we are not talking about any functional automated tool like QTP or Selenium or more.
Okay.
So we are just talking about the complete tools, where the tools will be helpful, how tools will be helpful, how we need to perform the activities by using those tools.
Okay.
So these all 6 chapters we are going to discuss as part of the foundation level syllabus.
Okay.
So and actually this information is available in ISTQB website. So the marks will also be given here. So there is a separate actually page where we can look at how many marks will be allocated for each chapter.
Okay.
So in a manner we can follow and we can achieve the certification.
Okay.
So this is the basic idea about this ISTQB syllabus. So now we go to the first chapter and try to discuss a few things which are very basics. So the first chapter is talking about the principles of testing. That is nothing but fundamentals of testing.
Okay.
So as part of this chapter, we are going to discuss a few contents like what is testing, so why testing is necessary, what is the fundamental test process, that means what kind of process we usually follow to test the softwares, then psychology of testing, that means as a test engineer what kind of attitude we must have, and by using that attitude how best we can break down the application. So that is psychology of testing. Then the types of testing like retesting, regression testing. Then based on instance of time, then how we need to prioritize the tests according to the criteria or else according to the timelines, how best you give to the application. So these all things we are going to discuss as part of the first chapter.
Okay.
So let's start with the testing definition or else testing terminology like. So as we already discussed, testing is a process. Anybody can define their own idea on this particular testing. So that is the reason no generally accepted set of testing definitions used worldwide. That means that so we cannot say that this is the hardcore definition for testing, because so if I feel that whatever I am following is correct and I am achieving very good results, I can define my own way. And if you can say the same thing and you can define your own way, because testing is a process, right? So that is the reason actually there is no global definition for this testing. But simply if we want to follow some kind of standard to define this, that is basically BS, British Standard 7925. This is one of the standards which defined by the British board. So according to their definitions, glossary of testing terms, the main emphasis is on component testing. That means that so you usually test the software with the intention of finding mistakes, or else it is a process of evaluating the system with the intention of finding the mistakes in a to achieve the better quality. So that is basically their own way of defining this. Then basically this particular definition is developed by branch of BTS CGS. So this is also a governance body which defines this. According to that, they taken this. So from this British standard and the BCS CGS, the ISTQB board adopted this, and they are following the definition of this testing. So generally, we're talking about testing like we do testing with the intention of finding mistakes.
Yeah.
Generally, we perform testing with the intention of finding mistakes. So if I consider about some problem in the application, so sometimes I'll say the mistake in the application or else defect in the application, bug in the problem. So we use so many different jargons like this. But here, according to ISTQB, so we have to define exactly. So at which kind of instance we have to use these kind of terminologies. So for an example, here they have given 3 different jargons like error, fault, and failure. So what is an error? Generally, error means a human action that produces an incorrect result. So here we apply this to the software. Generally, a developer will write the program. So while he is writing program, he may go wrong, and then the mistakes can be occurred in the program. So that means that due to the mistake of the developer, or else due to the developer action, some mistakes are occurring on the program. So that is basically, so with the intervention of the human, if something goes wrong, that will be called as error. So here generally in the development environment, whatever the deviation you find out in the program, that will usually be called as error. So generally if we find out any error in the program, then obviously so we can rectify that. So just assume that so we haven't identified any mistake. So that means that the mistake is hidden in the program. That does not mean that there is no mistake in this program. That means that probably the mistake is hidden in the program. So obviously, when we are not able to identify the mistake in the program, that will lead to the software. So because software is nothing but a series of programs. So here once the developer will write the program, and that program will be deployed into the relative servers. That's the way we are getting the front end, the application. So whatever the mistake the developer is not able to identify in the program, obviously the defect will be led to the software. So whenever you find some kind of odd behavior or else deviation in the expected result on the software, that will be called as fault. Fault or bug or defect. These are like synonyms. Fault or bug or defect. So fault is nothing but a manifestation of an error in the software. That means whatever the mistake which is left out in the program, that will be coming and sitting on the software. Basically, on the software, whatever the deviation we find out according to the customer expectation, that will be called as fault. So just assume that even on the software also we fail to find out. That means that so obviously the defect is hidden in the software. So now so we just release this to the end market, like into production. So whenever we release it to the production, the end users will use this software. So whenever the end user is using the software and and the behavior of the software does not meet his expectation, the time he feels that the application is failed. So overall, the deviation of the software from its expected delivery or service, so that can be considered as the failure. So failure will always be occurred at the production environment, at the end user side. Fault will always be occurred at the tester side. Error will always be happen at the developer side. So that is the reason usually developer can call that as error or mistake. The test engineer will call the deviation as fault or bug or defect. Then an end user will call that as the failure if at all something deviated from his expectation. So there is the reason here they're saying like failure is an event, that means that will happen. So fault is a state of the software, that there is a presence of the defect on the software, so which is caused by an error. So probably the root cause is the error. So from error that leads to the fault and that goes and fail in the production. So the same thing actually we are showing here. So generally a person makes an error. If at all he does not realize that, then he will go and presence on the software. Even we could not find out that, then obviously that goes and failed in the production.
Okay.
So now, according to our discussion, so there are mistakes in the program, there are defects in the software, and there may be a possibility to fail the software in the production as well. So can we find out all the defects on the software just to avoid the failure in the production? Is it possible to find out all the number of defects which are present in the software? Probably no. We cannot find all the defects which are present in the application. Because the only one reason that we all humans, our brains will be having some limitation. Due to that limitation, we cannot find all the defects. So, if at all we are not able to find all the defects in the software, that may cause the failure. So this is for sure. So now we try to correlate this aspect to our real-time scenarios. Whatever the applications or whatever the products we are using every day in our daily life. So is those all defect-free software or defect-free products or also defect-free things? Probably no. But though those products or though the things are used by us, those may be having some faults in it. But whenever we are using those will be working fine. That's the reason actually we are existing with that and we are using those. So if at all, whatever the action you are performing on those, and for your actions it is not responding properly, that time you won't use that. So till the time you perform some action and you get the very good results, then you won't mind it and use it. So if at all if it fails while you are using, you never use it. So that is the usual thing. So whenever, so here the thing is like we usually say that as the reliability, like trustworthy. So whenever you feel trust about something, you go on using it. If at all that is not usable for your necessity, then obviously that will get failed in the market. So that time actually you will see that as unreliable product. So that is not useful for you.
Okay.
So here the thing is the probability that software will not cause the failure of the system for a specified time under specified conditions. That means whenever we are using the software in the particular time, it will not cause any failure. So actually you reliable that. You reliable on it and you use it. So whenever you use in the particular time and if it is not working, then that time you say that is not reliable. That means you won't trust it. Then you won't use. So that is basically the reliability. So a software is also a reliable thing, though it is having defects in it, but it can be useful for the end user. While he is using, if it produces any defects, then he will say that is unreliable software. So as long as you are using that software and you are happy with that, then you say that as reliable software and you use it. So that's the reason here they're saying, can a system be fault free? Is it possible? So obviously no. So obviously system never be fault free, because it's always an exaggeration to say the system is fault free. So can a software system be reliable but still have faults? Probably. Though the software is having faults in it, but it can best usable to the end user. So this statement is correct. So is a fault-free software application always reliable? So if it is a fault-free software, then definitely it is reliable. But so according to the first statement, it is impossible to have the fault-free application. So that is the reason actually the third is wrong. So based on this slide, actually what we can understand is software is a reliable product, because though the software is having faults in it, we can best use that software according to our need. Then only we will be reliable on that software and we trust that and we will use it, or else we won't use it. Then why usually faults occur in the software? So the one thing is, we already discussed that generally the software is being developed by the humans. So whenever there is a manual intervention, so we do make mistakes. So probably it is our nature to make the mistakes. There is the reason we may go wrong in implementing something. So software is written by the human beings. So one reason is we know something but not everything. So we are not experts or masters in one thing. So we'll know something but not completely everything. So because of not knowing everything, we may go wrong, or else we assume in that area and we implement things. That may go wrong. Then who has skills but are not perfect? So one way that nowadays actually everybody is having multiple skills, but so those people are not perfect in every skill. So they may know about different things, but they are not perfect in all. So in a similar manner, so here the developer also have skill, but he is not perfect in particular area. That is the reason he is not able to do perfectly. Then other thing is we generally make mistakes. Probably this is our usual thing, general nature. So that's how the faults will place in the program. And then the second part is, so whenever we say software, we generally work in the timelines. So probably when it comes to the developers, then they always need to complete the task within the defined time. So at times, because of meeting that tight deadlines, they may undergo with the pressure, stress. So that pressure and stress will influence on their mind, attitude. So because of not having the sufficient time, breathing time, they may undergo with the pressure and stress. So these, because of these two elements, so they cannot check all things perfectly. So that time actually they take assumptions, and those assumptions will not work always. So that may go wrong. And because of not having the sufficient time, so they may not implement the complete system within the time, so that the applications will be incomplete, and there we can find out the mistakes. So generally here they are saying, like, if at all we ever involve in this particular thing, we come to know about this situation. So these are like the basic things why the faults are occurring in the software. So straight away, if we want to say, like, because of the manual intervention, we are getting the faults in the software. What do software faults cost? So that means that, so if at all there is a fault on the software, what happens? What it costs? Like generally we say that, so generally the faults will be categorized into high level faults, medium level faults, and low level faults. So if it is a low level fault, so will it cost anything? So here cost in the sense, what kind of financial loss it will representing. Probably at times, so we may not realize this thing usually. So even in the history, because of the comma and full stop, there was the huge financial losses. So, for an example, actually, in earlier days, there was a Mercury rocket. So, in that Mercury rocket, the developers, while the developers were implementing the program, so one of the developers they went wrong in writing the program. So uh, instead of putting the comma in one statement, they just put the full stop. Because of the full stop, the entire Mercury rocket got failed out. Soon after the Mercury rocket launches, then immediately that got crashed out. So the one thing is that, so whenever we are developing something, we have to be very keen about some things. Even the small things also will cause the huge failures. So as like that, actually, there are different instances. Here they have given huge sums of loss, like $7 billion of loss with the Ariane 5. Then in the same way, some Mariner Space, then American Airlines. This is all related to airlines and spacecrafts. So probably there is a small glitch in the software. That glitch causes the huge failure. So at times, very little they may not do anything. And if you observe the last thing, software is not linear. That means software will not behave always the same way. So even the small inputs may have very large effects. So as just now we have discussed about one example regarding Mercury rocket. So there is small input like common full stop causes the huge failure of the software. So that is the reason while we are testing the software, we have to be very, very careful. So here one more example they have given, like safety critical systems. So safety critical systems in the sense the risky oriented softwares. So generally the airline software, then defense oriented, health related softwares, diagnosis. So these kind of softwares are very critical in nature. The risk is very more in such kind of softwares. So whenever as a test engineer or developer, they have to be very very strong while they are developing or testing such kind of application. So since this is very risky software, so obviously this will cause huge impact on the financial. So that's the reason actually you have to be very careful implementing these things. So
Okay.
software faults can cause death or injury, like radiation treatment kills patients, like diagnosis centers will be using this kind of things. Then aircraft crashes, then bank system overdraft letters cause suicide. So that means that, so if there is a small glitch in the software which is used in the bank, due to that actually the calculation is so wrong. If there is a wrong in the calculation, obviously banks cannot give the proper draft letters to the customers. Due to this, actually, the people, end users like us, we may attack with the cardiac arrest kind of things. So that's the reason actually these are so critical to look at. So we stop here for today.
Okay.